also discuss the sterilization, disinfection of water to avoid the pathogenic bacteria. So this is the fourth topic in water technology. So you can watch my all previous videos about water technology as well as electrochemistry, corrosion in my channel. The links was provided in the description. So the land is full of water. 70% of globe is filled with the water. But water, what is around you is drinkable? Definitely not. Why? Because it is contaminated by the different types of contaminations like dissolved gases, dissolved minerals, suspended solids, organic matter, and biological contaminants. So the water which is able to drink, which is able to human consumption, is called potable water. That water should be free from any contaminants, and that water is also called potable water and also municipal water. Municipalities collect the water and will be transferred to the human consumption across the cities and their municipalities. So that's why this is also called municipal water. So what is the specifications of potable water? Potable water should be clear, smellless and have a good taste, and its turbidity should be less than the 10 ppm, and drinking water pH should be higher than the 7, and means 7 to 8 pH should be lies between the 7 to 8. That means it should be alkaline nature, that then only it is good for the health. And it should not neither too hard or too soft. That means oddness, that means calcium and magnesium salt should be present in the water, but the range is not over than 300 ppm and also not less than 100 ppm. And TDS, total dissolved salts, that means along with magnesium and calcium, the other salts like copper, iron, all the salts present is called total dissolved salts, and it should not be greater than 500 ppm. So by mistake I have written less than, but it is a greater than 500 ppm. And the drinking water should not contain any harmful dissolved gases like CO2 and H2S, and it should not contain any organic matter and also solids like lead and arsenic. Those are the toxic metals, so they should not contain all these things. So if the water following this specification, then that water only useful for drinking purpose. So how municipality is collecting water and how they transfer water to people. In between these two processes, they need to purify the water. That process is called municipal water treatment. So now we are going to discuss about the municipal water treatment. The first one, they collect the water by screening. Screening means they flow the water into the large tanks which are having these small pores, so the water only come out large objects like plastic, wood, stones. These type of large objects will be stay on the tanks only. Like that we can avoid the large objects from the screening process. Okay. Then aeration. Aeration means mixing of air with water is called aeration. If water already contains some dissolved gases like harmful dissolved gases like CO2, H2S, when you pass the fresh air, so water having some saturation level to dissolve the air. So when you pass the fresh air, it leaves reveals the already presented bad air or toxic air in the water. So water gets fresh, and fresh air also gives the increase the dissolved oxygen content. It gives the freshness to the water and it removes the odor of the water. Okay, so this is the process is called aeration. And next one is sedimentation. Sedimentation process is subjected to remove the suspended particles. Suspended particles means like sand, mud, all these particles are suspended particles. They are mixed with the water. So for example, when you take a water in a bottle, if you add some small sand particles and if you mix it vigorously, you shake it, and if you keep the bottle at the place for constantly for some time, then all sand particle will come down and settle down because of gravitational force. So the particle size is comparatively high, so because of gravitational force they will slowly come down and settle down. Then we can easily separate that suspend particle from the water. The same principle we apply here. When you keep water in a large tanks without disturbing anything, so these all suspended particles will be settled down here. So you can see at bottom side, because of gravitational force, all these suspended particles are settled down here without disturbing this one. This pure water is separated and passed to the other tanks. So this is a sequence. That means first we need to do screening. After that, that water is subjected to aeration. Next, that water is sent to sedimentation process. Now the this resulted water is sent to the next process. That next process, coagulation. Coagulation means some colloidal particle, finely divided silica, finely clay particle. These are not separated by the gravitational force. They are not settled down under the under part of the container because of gravitational force. Why? Because there is no gravitational force applied on these such small particles. So those are called colloidal particles, but colloidal particles having a characteristic charge on it. So when you add some coagulants like sodium aluminate, ferrous sulfate, alum, like this, if you add, there's called coagulants. Coagulants having a opposite charge to the colloidal particles. Now this coagulants attracts the all colloidal particles. If you can see here, so when we are adding coagulants, yellow color coagulants, these coagulants attracts the opposite charged particles. Now the size of the coagulants is increased. So when the size is increased, automatically gravitational force will apply on the particles. They come down very slow, they slowly come down and settle down. So now as coagulation, as sedimentation process, all the colloidal particles also settle down. Now we can separate all colloidal particles by using motors or something. So like that we can also remove the coagulants or colloidal particles. So next one is filtration. So filtration is the process of removal of coarse impurities, color, taste, and some of the organic microorganisms. Not fully, but it is effectively can remove some watering agents. So when you pass the water over the fine sand, coarse sand, fine granule, and core granules. So when you pass the water through the different layers, so we know groundwater is pure water than the stored water or surface water. Why? Because when the water is percolated into the earth crust, the earth layers will purify the water. They will be abstract the all different types of salt and organic matter. So groundwater is very safe for consumption than the others. So that principle we applied here artificially. We make a different layers in a operator. So when we pass this water through these layers, the water automatically filtered, and this is example of gravity sand filter. So like that we can remove the ordering and coloring agents, some of the microorganisms. So up to now we did the screening process to remove the large objects, and aeration to remove the dissolved gases, and sedimentation process to remove the suspended particles, coagulation method to remove the colloidal particles, and filtration method to remove the odor and coloring agents. But after these all these five processes, still pathogenic bacteria present in the water. So pathogenic bacteria means hill diseasing agents or hill diseasing bacteria, virus. These are called pathogenic bacteria. After all this process, still water contain pathogenic bacteria. If the water is used to drinking purpose, you should remove pathogenic bacteria. The removing or killing process of pathogenic bacteria is called sterilization or disinfection. So sterilization, disinfection both are technically different but nearly same meaning. Sterilization mean removing, killing of all pathogenic bacteria from the water is called sterilization. Disinfection mean removing or decreasing of pathogenic bacteria present in the water is called disinfection. No problem, we can combinedly we can tell like this: remove or killing of all pathogenic bacteria present in the water is called sterilization and disinfection method. This is also called decontamination process. So We have so many methods for a decontamination process. Those are boiling of the water, ozone usage, ultraviolet radiation, and the best practical method is chlorination. So we will discuss about these. So first method is boiling. When you boil the water around 15 to 20 minutes, so all pathogenic bacteria will kill, because of when we are giving high heat energy, so bacteria will automatically killed by the thermal energy. So this is the best usage in the household purpose. It is only used for the 1 or 2 liters water can be used for the boiling purpose to sterilization process, but it is not a good approach for a large amount of water. Why? Because municipalities or industry cannot afford the to processing by boiling process. Why we need to use more electricity or more fuel to generate the heat energy. So this is the one of the process, and also this process only protect the water up to 2 to 3 hours after boiling. Again fresh bacteria will generated in the water, so it is not protect the water from further contamination process. So this is the boiling, and next one is ozone adding. So when you add ozone is a very active molecule. So when ozone at atmosphere, when you leave the ozone in the normal atmosphere, it immediately give the nascent oxygen. That nascent oxygen is a strong oxidizing agent. So oxidizing agent always oxidizes the others. It oxidizes the bacteria. That means bacteria or pathogenic bacteria involved in oxidation. Oxidation means losing of electrons. When the bacteria or pathogenic viruses are involved in oxidation, they loses electron, they become weak, and finally it leads to their death. So when you add ozone is a good oxidizing agent. It kills all pathogenic bacteria, but ozone is an unstable one. The production of ozone and storage of ozone both are both are not economical. That's why this process also not approachable for normal purpose. So next one is by using ultraviolet radiation. So we know ultraviolet radiations are very much higher energetic radiation than the IR and visible radiation. So what we are feeling in present radiation is IR and UV radiation. Sorry, IR and visible radiation. So because of visible radiation, we are able to see the different. We are able to identify the different colors. Because of IR radiation, we are feeling the heat on the atmosphere, but UV radiation is very higher energetic than the IR and visible radiation. So they have higher energy. When you pass this higher energetic radiation over the bacteria, so bacteria will kill it by this high energy. So like that we can purify the water from pathogenic bacteria. But the again production of UV radiation is very high cost. That's why this is also not approachable for normal purpose, but it mostly used in the sterilize the swimming pools in high cost hotels like 5-star hotels like that. So these three methods are good, but they have their own limitations. So next one is practical approaching is chlorination. Chlorination means by adding chlorine to the water, chlorine in the form of liquid or solid or gaseous, any form. So when you add some chlorine to the water, it can kill the all pathogenic bacteria from the water. This is called chlorination method in sterilization or disinfection. The first one is we can add chlorine in the form of gas or liquid or solid. First of all, if you add chlorine gas directly to the water, what will happen? So when you add chlorine gas to the water, chlorine interacts with the water and produces the hypochlorous acid, HOCl, hypochlorous acid, and HCl. This hypochlorous acid is a very strong oxidizing agent. It kills all pathogenic bacteria. So by breaking the chemical bonds in the molecule, so HOCl is oxidizing agent. It oxidizes the bacteria. So bacteria involved in removing process. So this is the process of adding chlorination. But there is a disadvantage. Chlorine has a pungent smell. It's import the different taste to the water and smell to the water. So it is not it not give the pleasant experience to the consumer. So and also chlorine is a gas. The storage also is another problem. So and chlorine is a very active gas. It immediately interact with the water. It immediately produces HOCl. So the HOCl kills the bacteria present in the water. But immediately the HOCl is produced HOCl is reactive and it is consumed totally. Because of this one, it cannot protect water from further contamination. So next one is bleaching powder. Bleaching powder means calcium oxychloride, or it also called calcium hypochlorite. So CaOCl2. When you add CaOCl2 bleaching powder to water, first of all it produces the calcium hydroxide and Cl2 gas. So here we are just taking calcium oxychloride alternative for the chlorine gas. Why? Because it again producing chlorine gas. Here we are adding directly chlorine gas to water, but we are adding bleaching powder, a solid, to the water. When we add bleaching powder to water, first it produces the chlorine gas. Next process same as above, this chlorine gas interact with the water and it produces the HOCl. This HOCl is a strong oxidizing agent, it kills the bacteria. But here also, in the between the reaction, there is a formation of Cl2. It has a pungent smell. It gives the different taste and odor to the water. It is unpleasant to the for consumption process. So, and also bleaching powder is also very active. If it is contact with the moisture present atmosphere, it immediately chlorine gas is released and it is escape into the atmosphere. So in the bags only calcium hydroxide, that means lime only stay on the bags, it is not useful. Okay, so and 1 kg of bleaching powder is sufficient to sterilize the 1 million liters of water. So it is a best option. Generally we are using in villages, the municipalities or panchayatis always, and they come and give the bleaching powder to our wells and the roadside canals. Why? Because it can kill the all bacteria present in the surface. And these days, like corona COVID-19 situation also, bleaching powder is very famous. So when you use bleaching powder, because of this oxidizing property, when it is interacted with the moisture, it produces the HOCl. It kills the all pathogenic bacteria. So next one is chloramine. Chloramine means aminochlorine or chloramines. When you add chlorine gas to ammonia, it produces aminochlorine. So aminochlorines can be prepared in the laboratories. Now this aminochlorine, so NH2Cl can directly add to the water. When you add the aminochlorine to water, it produces the directly HOCl without producing any Cl2 gas. See here, first of all, we need to prepare the aminochlorine laboratory. So Cl2 plus ammonia gives NH2Cl. So this NH2Cl, when it is added to the water, it producing the HOCl and also ammonia. Ammonia is a it is easily can remove from the water by giving the little bit high temperature. HOCl is disinfectant, it is a strong oxidizing agent, it kills the bacteria. And another advantage is here no Cl2 gas, that's why no pungent smell, first one. And second one is NH2Cl is a not highly reactive molecule as like bleaching powder or chlorine gas. So it is a slow reactive, that's why it's slowly stepwisely releasing HOCl. Because of this process, the present bacteria in the water kills by the producing HOCl. And when you add HOCl some quantity, it not immediately converting into total HOCl, it's slowly converting. Rate of reaction is very slow, so it's slowly converting into HOCl. So further protection also available because of NH2Cl. This is the most important advantage of the chloramines. So if you want to kill bacteria immediately, you can go for this Cl2 or bleaching powder. If you want to protect water from for the further protection, you go with the chloramines. Okay. So and next one is breakpoint of chlorination. So what is breakpoint of chlorination? At which point the chlorine demands has been totally satisfied is called breakpoint of chlorination. That was the definition. So what is breakpoint? When you, for example, so there is a graph here, you can see here in x-axis how much chlorine is added to the water is measured. In y-axis, after adding that water is tested for the how much chlorine present in the water. So for example, you added x grams into the water, but x grams is there or not, it can be tested by the laboratory. So laboratory results are given in the y-axis. Okay. So added one and tested one. So these are the graph drawn. So if you see here, so when you add chlorine gas, it kills the bacteria. So how much chlorine is required to kill all pathogenic bacteria present in the water? So that amount, that point is called breakpoint of chlorination. Okay. So you can see here. So first of all, you are adding chlorine gas to the water here. Up to here, this much of chlorine gas is you added. But when you tested that water in laboratory, it's showing zero amount. That means even though you added chlorine gas, but there is no chlorine residue in the water because of some of the reducing agent. Chlorine is reduced by the reducing compounds. Okay, chlorine is a oxidizing agent, so that's why it oxidizes the others. That means it itself it involved in reduction. So this means some of the reducing agent reducing the chlorine, so there is no chlorine present in the water even though you added up to this point. Okay. So after this point, what you are adding chlorine gas is interact with the ammonia something in the water. So it forms the chloroamines. That's why. So chloroamine means nothing but chlorine. So it's showing the high amount of chlorine. Chlorine residue is high amount up at this point. Okay. Next, after this point, now the chloroamines start to interact with the bacteria present in the water. So all pathogenic bacteria are interact with the chloroamines, and chloroamine destruction the chloramine kills the all pathogenic bacteria. That means chloroamine also involved in consumption. So slowly chloroamine content is decreased here. So after that again it is increasing means there is no pathogenic bacteria. All pathogenic bacteria are killed. That's why chlorine content is increasing by adding chlorine gas or aminochlorine gas. So at this point, what can we conclude? In the water, all reducing agent, all ammonia content, and all pathogenic bacteria, all are removed from the water by adding this much amount of chlorine. So this point is called breakpoint of chlorination. If you add still chlorine, it's continuously increasing. So and also from this point, it is not only giving the information how much chlorine gas is required to kill pathogenic bacteria, but also it gives the how much is chlorine is required for further protection. For example, if you want to protect the water 1 week, how much chlorine you need to add. That information also given by this breakpoint of chlorination graph. So this is the breakpoint of chlorination. So finally, municipality has to perfectly and properly has to do all these actions, then only people are safe when they consume the water. Why? Because what we have around the water, these all are not acceptable for drinking purpose. They are fully contaminated. So please aware, don't drink any water what you have. So be aware of what is present in your water. Okay, thank you for listening.